Good day, my dear friends. Today is for your attention the problem solving according to our topic basic concepts and laws of electrical circuit. In this scheme, we have inductor and capacitor that is connected to the common node. Another hand of this node we can see resistor R3 and capacitor C3. We know the parameters of all of these elements, and among them we know that voltage on inductor L1 is 5 times T2, and voltage on capacitor C3 is 50 times T power 4. We need to determine the voltage U23. As you can see, this voltage acts between the point number 2, what is point number, this is point number 2, and point number 3. To solve this problem, we have to use the relationships between currents and voltages of passive elements. These relationships shown in this slide, in this table. First of all, we need to set the conditional positive directions of current in the branches. For example, as it shown in this scheme, current number 1, current number 2, and current number 3. Note that if we already have directions of each current, we already know about directions of all voltages in this scheme, because the current and voltage in on passive elements is the same. So our voltage U23 we can find according to Kirchhoff's second law. Let me look this mesh. This mesh consists of voltage UC2, voltage UR3, and voltage UC3, and of course voltage U23. We can write the Kirchhoff's second law equation as let me go around this mesh clockwise, and firstly we meet in our page voltage UC2. Direction of this voltage is the same with our positive direction of page of this message. So UC2 we should take in this equation in the plus sign. Voltage UR3 and voltage UC3 we write down to the plus sign 2. And now we are in the point number 3, and we should go from this point to the point number 2, and we are going contrary from the directions of U32. So this voltage U32 we need to write with the minus sign. The algebraic sum of these four voltages is 0. From this equation we can find that U23 is UC2 plus UR3 plus UC3. Voltage UC3, we already know what is this voltage. So we need to find next to voltage UC2 and voltage UR3. Voltage UC2 we can find from the relationships between the voltage and current for the capacitor. Relationships between the voltage and current in the capacitor. We know we can see that this voltage is 1 over C2 times integral of I2 dt. As we can see from this formula, we need to obtain the current, the value of the current I2. Current I2 we can obtain from Kirchhoff's first law. This current is comes to this node, so we need to write it in a plus sign, I1 in plus sign 2, and the current I3 that goes from this node we can write with minus sign. From this equation we obtain that I2 is equal I3 minus I1. Current I1 acts in inductor L1, and we already know the voltages of this inductor. So we can use the relationships between voltage and current of inductor. Relationship between voltage and current. We also know voltage, and we need to obtain current. What is this formula? We can write this formula in our case as 1 over L1 multiplied by integral UL1 dt. Now we substitute the values of parameters of our scheme. Inductance of inductor L1 is 5 Henry. What is this? 5 Henry. 5 times 2 power t power 2 is the voltage of these inductors. After calculations, we can obtain that the current I1 is equal 0.33 multiplied by t cube. Now we can obtain the current I3 that acts in capacitor C3. We can find this current using the formula. What is this formula? We know voltage on the capacitor C3 in our case, and we should obtain current of this capacitor. In our case, this is I3. This is C3 capacitance of this capacitor multiplied by this duc3 by dt. Then we substitute the parameters of our elements. 200 microfarads is 500 multiplied by 10 power minus 6 farads multiplied by derivative d50 multiplied t power 4 with respect of dt. So we have, as we know, that this derivative of t4 with respect of dt is 4 multiplied by t power 3, and we have, after calculations, 0.04 multiplied by t cube. This is a value of current I3. If we already know current I3, then we can find the voltage UR3 according to this formula. We know this current and we should obtain this voltage. According to this formula, we substitute our data. 500 ohms is a resistance of this resistor R3, and we obtain that our voltage on this resistor is 20 times 2 cube volt. Current I2 we can obtain from Kirchhoff's law. We already know this equation. In this time we can substitute our values and obtain that current I2 is minus 0.29 multiplied by t cube amperes. What does it mean that this sign minus? That it means that the directions of this current is contrary. So this current acts from this common node to this point number 2. If we know the value of current I2, we can find the voltage of capacitor UC2, this voltage, according to this formula. According to this formula, we know current of this capacitor and we should know voltage of capacitor. 1 over C2 multiplied by integral I2 with respect of dt. We substitute our values. The voltage, capacitance of this capacitor C2 is 100 microfarads. That is 100 multiplied by 10 power minus 6. This is the value of this capacitance in farad. Integral of minus 0.29 t cube with respect dt, and our calculation, we can obtain that this voltage is minus 725 multiplied by t power 4 voltage. And now we are ready to write down the solution of our problem. The solution of our problem, the value of voltage UC2 is equal U23 is equal to the voltage UC2 plus UR3 plus UC3. This is a values of these voltages, and after calculation we have our solution. voltage U23 is equal 20 multiplied T cube minus 675 multiplied by T power 4. Our problem is solved. I thank you for your attention, my dear friends. Have a nice day. Goodbye.